Okay, welcome back. We're talking about the transaction keyword. So beginning this transaction means I want to have this select statement and this update statement to actually be together so that if one of them fails for whatever reason, or if somebody else is updating the quantity at the same time, they have to wait. So let's do a slightly better example. So here's an example of a bank account where I have an account holder, user number 12 has a checking account and a savings account. And he wants to transfer money from his savings account to his checking account. But I want to do this in a transaction, so if something goes wrong, I'm all right. So here's what the transaction would look like. Now, I'll confess there's an awful lot of stuff in here that we haven't covered, but just bear with me. So I update the account where I take $500 off of the account, and then I check to see if I'm below zero. If I am below zero, I throw an error. Otherwise, I commit the transaction. So what I'm going to do, I'm just going to run this, and let's go look at the account balance now. So instead of having, I should be able to go in here and say, whoop. So now it's 534, right? So let's just continue. Let's just do this one again. And okay, great. Let's go back to here. Let's do a refresh one more time. And it's 1,000. So let's try it one more time. All right, try it one last time. And I do not get it. So it does not do it the third time. That's what transactions are all about. Okay. Now, in some databases, each one of the statements could actually be have a transaction around them. So what we've been doing in SQL, whenever we do like an update here, like this, it would have automatically put this in a transaction. Okay? So do you remember when we were trying to, like, for example, convert data types? And so, we were running through, most of the data could convert. But if somebody put in TX or something that wasn't a number, it would fail. But it failed for all of them because it had an implicit transaction involved there. Now, that's not going to help you here because the machine's not going to know that this select, set, and update are all wrapped together. It's not that smart. Okay, so just saying, some databases, including SQL Server, will automatically wrap transactions around all updates automatically. And if you want more than that, like in this case, we wanted more, we would have to go in and do that. Okay, they introduced a term called ACID. Very cool. Let's just go through it. So the A of ACID stands for atomic. Atomic, one more time. Atomic means this is as far as I want you to take it. You cannot subdivide this thing. It's all or nothing. That's what atomic means. All or nothing. In other words, can't subdivide this select from that update. Can't do it. Okay, good. Consistent. Consistent basically means that if I do this again, it's going to work. In other words, consistency means if I do it a second time, I expect it to behave exactly the way it did the first time, right? Consistency. Isolation. My work shouldn't be affecting other people. Okay, when I do this, I shouldn't be messing up somebody else's work. Okay? And then durable. Durable means once it's done, it's done. Okay? Once I hit the commit, there's no undo after that, okay? Once the commit is done, it's committed. So ACID. Atomic, meaning can't be subdivided, or you don't want it to be subdivided. Consistent, which means it produces the same results all the time. Isolated means my work doesn't mess with yours. And durable means once it's done, it's done. Okay, now here's some crazy terms, and this is going to get a little wild here, so don't go crazy on this. I'm not asking you to memorize this thing, but I do want you to kind of sort of understand what this means. Okay, so a dirty read, which means, let's say that I have started a transaction, okay, and I've done some stuff, but I have not yet done a commit, right? It's a long-running transaction. Maybe it's got 15 statements in it. And while inside the middle of my transaction, you decide to read that table. Well, you could get some uncommitted data, okay? Data that is gonna change as soon as that commit occurs. So that's called a dirty read. Transaction reads a row has not changed, but the changes have changed, but they have not yet been committed. So if the change was rolled back, well, then you got the wrong data. So, that's bad. Repeatable read, which means, let's say for some reason you have to read a table and then in whatever process you're doing, you have to read it a second time, and you don't want anything to change in between. The transaction rereads the data that it has just changed and finds things that have happened. Oh my goodness, that's a non-repeatable read. And then a phantom read is, so I reread the data and I find brand new rows, right? So the example of somebody adding changing the minimum wage while I'm inserting a new employee, it changed those. But when you reread the data, it goes, whoa, where did this person come from? So that's a description of these issues. Okay. So they call these isolation levels in Microsoft SQL Server. So when we get to Chapter 10, we'll talk about this in a little bit more detail. Okay, so here's the transaction kind of thing. Again, don't get this too complicated, all right? So this is describing the problem, and here's the types of isolation that you could have. Read uncommitted, which means, is it okay for me to get the data that has in the process of being changed? That's one of the isolation levels. Read committed means, no, man, I'm going to wait until that commit occurs. Repeatable read is, okay, I need to go in there and every time I read this table, it's going to give me the exact same answer. And then serializing basically takes that example here. Hang on a second. Let me get back to this guy. This example and says, not happening. I'm going to do all of user A's stuff and then followed by all their users B's stuff. Okay? That's pretty rare. Serialization basically tells the machine, I don't want you doing two things at once. I want you to do one thing at a time. Now, serialization is the big daddy. That's the big daddy of how to solve a concurrency problem. It's also probably the worst for its performance. So a lot of people don't do that. Okay, once again, I'm not asking you to memorize this, but you kind of see how the problem and then what type of isolation you would apply to it to solve this problem. Okay. Next thing you talk about is cursors. And by now you're probably cursing at this course, I would imagine. This is mostly for programmers, and so quite frankly, I'm going to skip over this topic. It's a concept that if you're not a programmer, your probably eyes are going to roll back in your head probably even more than they are now. Let's move on to a completely different topic on page 477, and that's security. So we've learned the TCL, transaction control language, and now we're going to learn the data control language, DCL. So DCL is all about permissions. This is where you would grant permission, revoke permission, deny permissions. Okay. So here's an example of permissions, okay? So I have a user, actually several users, Eleanor and James and Richard, and they have roles like accounting, tellers, top, whatever. And then, so a person could be in a role, and then permissions, and then, so I take the user permissions and the role permissions and meld them together and figure out what the final permissions should be. So for example, if Richard had read permission, but as that person is in the accounting role, and the accounting role has read and write, well then they get both read and write. Okay? Now, just as a note, it's always best to not use individual users and to use roles instead. That's an excellent thing to write down. Excellent thing to remember. Here's how it works. So in real life, they get a brand new employee in the accounting group, and so the head accountant person comes up and says, hey, we just hired Bob over here, and he's our new guy in the accounting. You need to set up his permissions on the database. And I'll say, well, what kind of permissions do they need? And they go, I don't know, the same as what Jill had. That is exactly the answer you're going to get, because they're not in the databases. They don't know the permissions. They're going to do it by role. They're going to say, oh, okay, well, Jill was in the accounting group, therefore I'll just put Bob into the accounting group and presto changeo. I don't have to go in and do anything. All I have to do is just put them in the right group, and the database automatically has all the permissions that it needs. So it's a heck of a lot more sense to use roles. First of all, if you have 500 employees in your organization, you got 10 roles, doesn't it make sense to operate on the 10 rather than the 500? Save yourself some work? Okay, good. Hope you understand that. So, using this example, what permissions or roles would apply here? The next thing we're actually going to do this, but not in Chapter 9. We're actually going to go in, and when we get to Chapter 10, I'm going to show you specifically creating users, creating roles, and then applying permissions. It's a bit much because it is database specific, so I'm just going to wave my hand and say, yes, all these things will happen. We're going to do this. We're going to set up users, we're going to set up roles, we're going to set up permissions, we're going to assign those permissions to an object. Okay, so continuing. So you may remember or not, when we first installed a SQL Server, one of the things it asked for was if we wanted to use integrated security, or what they called the Windows Authentication. And the other was called SQL Server Authentication. So when we log in, okay, if I was to log out of this guy and then connect back to it. So one of the choices is Windows Authentication, and the other is SQL Server. So we didn't set it up for that, but you basically have two choices. Windows Authentication makes sense, and then the SQL Server Authentication. So SQL Server Authentication is great if you're not on Windows, right? If you're on a Linux machine or Mac or something else, well then clearly you can't be using Windows Authentication because you're not on Windows. So in the corporate world, it's pretty common to use Windows Authentication, but if everyone has the same machine type, right? Okay, good. So we're going to be talking about this a great deal. The current logon account, that way when I connect to this, I don't have to have another password. I hate having yet another name and password. Jeez. So I prefer this technique, which is why we used it. So there's some guidelines on how to set up these things. And so the guidelines basically are, run your database management behind a firewall. Okay, yep. And then plan for your firewall to be breached. Okay. Apply the latest operating systems and, patches stuff. That's fairly obvious. The least functionality. In other words, if you typically only use one network protocol, I'm using TCP/IP and nothing else, well then turn off the others. Because SQL Server can operate through all different types of protocols. So just enable the one thing that you do use. Turn off unused systems. Disable logins. And then protect the computer itself. I mean, don't ever allow the users to sit at the server. They're always going to be over there on their machine, sitting at their desk with their PC and connected via the network. Don't ever let people walk into the server room and sit down at the SQL Server machine. So, I need to do an update. That ain't right. Manage accounts and privileges. Use low-level privileges for the services that run, protecting the accounts with strong password, monitoring failed attempts, blah, blah, blah. Check the roles and memberships to make sure they are what they expect. Have some auditing going on. That's pretty cool. And then planning. Develop a security plan for preventing and detecting problems and then how to do it. Okay, we have an entire course on how to do security. So this is kind of a thing. So let's just talk about the attack surface. I want to reduce the attack surface. What that basically means is if my SQL Server has 4 different ways to communicate, but I'm only using one, why don't I just disable the other 3? Okay, reducing the attack surface. Isolating tasks, and then make sure you have nice passwords and all the rest of those kinds. On page 482, they start talking about applications. So what's the granularity when I do a grant, for example? Can I use a grant at the row level? So if I grant permission, it's typically going to be on a database object, a view, a table, a stored procedure, a function. Typically, it's not used down at the row level. But we'll continue this discussion in just a few.